Okay, so today we're going to start with the power series. Okay, so a power series really just has the general form, let's say the sum from, not I, from n equals 0 to infinity of some constant times x minus a to the nth power. Where if n is equal to 0, you just have c sub 0. If n is equal to 1, you have c sub 1 times x minus a. C is equal to 2. N is equal to 2, sorry. You have c sub 2 times x minus a squared. And it just keeps on going. Okay. Now this power series is centered at whatever a is. So whatever value a is, that's where it's centered. Clean that a up a little bit. And the c sub n's are coefficients. Move this out the way. Okay, so for example, the sum from n equals 0 to infinity of c sub n times x to the nth power is just a power series centered at 0. It's just like saying x minus 0 to the nth power. So that would be c1 plus, c0. Don't know why I'm starting at 1. c0 plus c1 x plus c2 x squared, and it just keeps on going. So this is a power series. Centered at 0. Okay, so let's say if we had the example of, say the sum from n equals 0 to infinity of x to the nth power over n factorial. Okay. Plug in 0, you get 1. X to the 0 power over 0 factorial is just 1. Plug in x equals 1, that's just x. Plug in x equals 2, that's really 1/2, I guess you could say x squared over 2 factorial. Then you have x cubed over 3 factorial. And again, that's just a power series centered at 0. Okay. But if you had something like, say the sum from n equals 0 to infinity of -1 to the nth power times x plus 1 to the nth power, where if you plug in 0, you just have 1. If you plug in 1, that'll be -1 to the first power, so that'll be negative x plus 1. Plug in 2, you have -1 and -1 squared, which is 1. X plus 1 squared minus x plus 1 to the third, and it keeps on going. So this is a power series, but it's centered at -1. Because remember, it's x minus a. Okay, but let's say if you have the sum from n equals 0 to infinity of the square root of x over n plus 1. where if you plug in n equals 0, you have square root of x over 1. If you plug in n equals 1, you have, well, you can say 1 over square root of 2 times square root of x. If you plug in n equals 2, 1 over square root of 3 times square root of x, and it keeps on going. So if you rewrote that as x to the 1/2 plus 1 over square root of 2 x to the 1/2 plus 1 over square root of 3 x to the 1/2, and it keeps on going, this is actually not a power series. Really for two reasons. One, all of your x terms are the same. And two, they're fractions. Okay, so it's not going up between 0, 1, 2, etc., and so forth. Okay. Not a power series, since you have fractional exponents and the let me see. X terms are the same. If you notice the previous one, it always went up from x to the 0, x to the first, x to the second. Yes?
So what about if it's x to the 1 divided by n?
X to the 1 divided by n.
Yeah, like the exponent of x is 1 divided by n in the series. So it'll be fractional, but it's changing. It's not always the same. But that's
Oh, x. Oh, okay, I see what you're saying. X to the 1 divided by n.
Yeah.
With that one, it wouldn't be a power series because it would have to go up x to the 0, x to the first power. So whenever you have a fractional exponent, it wouldn't be considered a power series. Yeah.
Okay.
Okay. Any other questions on this one? All right. Keep that up there for a few more seconds.
What does it mean that the x terms are the same?
Oh, each of them are x to the 1/2, x to the 1/2, x to the 1/2.
Okay. Gotcha. Because it's not being raised to any n power.
Exactly, the exponent's not increasing. No, at least increasing to a whole number. All right, so we're going to look at the convergence of a power series. Okay. Now, when you have a power series, you have three different circumstances that can happen. So when you have a power series, clean that up a little bit. Centered at some value a, only one of the following can be true. Okay, so the series converges when x is equal to a, but it diverges for every other value. Uh-oh, and diverges. When x does not equal a. Okay, that's one option. Okay. Second option is it can converge for every value of x. Or converges absolutely, to be more specific. Okay. And the third option, and let's say there exists a real number, and we'll call that real number r. And it's greater than 0. So you have some positive real number such that the series converges absolutely for a specific circumstance. The series converges absolutely for the absolute value of x minus a is less than r. Oh, let me clean that up some. And diverges for the absolute value of x minus a is greater than that real number. Okay. Now, if r is equal to 1, then that's when you have to use a different test because you can't really tell anything there. So the absolute value of x minus a equals r means it could either converge or diverge. Okay. Now in this case, your r is going to equal your radius of convergence. Okay. Now if your r is equal to 0, that means it only converges at a, whatever your a value is. Now, if r is equal to infinity, then that means that your, oh, sure. That means it converges for any value of x. So when you have a specific set of numbers that your series can converge, that's called your interval of convergence. When you don't have just one specific point or every possible x, if you have just a certain number of x values. Move that up, so the set of values where x converges, and put a little quotation there, is the interval of convergence. Okay. And a lot of these, instead of radius of convergence, you'll see me just put ROC, and interval of convergence is, you'll see IOC. No other reason than it just gets really, really irritating writing that over and over and over and over again. Yes.
Okay, so it's the interval, right, so like from, I guess, the center, right, where the radius goes up to, is the center at where, whatever A is?
Yep, that would be your center. So if you have your radius, let's say if your interval is from, let's say -5 to 5, but it's centered at 0, then your radius would be 5. But your interval would be from -5 to 5. All right. All right. Okay. So to work with these, you want to remember your ratio test. It's not the only test you can do to find out whether it's absolutely convergent, but it's usually the quickest. Okay. So remember, if the limit of a sub n plus 1 over a sub n, well, the absolute value, as n approaches infinity, equals some limit, and that limit happens to be less than 1, then the series converges. So then the series, let's say the sum from,
What's the top term of that?
A sub n.
oh, a sub n plus 1.
Okay.
Yeah. And the series of a sub n is absolutely convergent. Okay. Now, 2, if that limit is less, well, it's greater than 1, or it's infinity, then it diverges. So if the limit as n approaches infinity of absolute value of a sub n plus 1 over a sub n equals L, and it's greater than 1, or that limit sub n plus 1 over a sub n equals infinity, then the series, you can go from n equals 0 or n equals 1. That part really is not that important. A sub n diverges. And if it's equal to 1, then it's inconclusive, and you have to use another test. So if the limit of the absolute value of a sub n plus 1 over a sub n as n approaches infinity, actually equals 1, then the ratio test is inconclusive, and another test must be used. Okay, so you want to remember your ratio test. And also you want to remember that absolute value of x, let's say if that's less than r, that's the same as saying x is between negative r and r. Because both of these are things we're going to use to solve the next couple of problems. Oh, yeah. Do you have a question?
Yeah.
Mhm.
What if the limit goes to negative infinity?
Oh, it would still diverge. Well, actually, it's the absolute value, so it would go to positive.
Okay, gotcha.
All right. All right. Ooh. Okay, so let's say, for example, it was still writing. Give it up for a few more seconds. All right, one of those, get that okay. So let's say, for example, if you want to find the radius of convergence, which is our ROC, of, say, the sum from n equals 0 to infinity of n factorial times x to the nth power. Okay, so we're going to let our a sub n equals n factorial times x to the nth power. Okay. So if we want to find out where it's absolutely convergent, just use the ratio test. So we have a sub n plus 1 over a sub n. Okay. That's going to equal your a sub n plus, oh, forgot my limit. Limit as n approaches infinity of a sub n plus 1. So that would be n plus 1 factorial times x to the n plus 1 power divided by a sub n, which is just n factorial times x to the nth power. Okay. Now n plus 1 factorial, kind of a little side note here. N plus 1 factorial, that's just equal to n plus 1 times n factorial. Okay, so we have the limit as n approaches infinity, the absolute value of n plus 1 times n factorial times x to the nth power times x. I didn't really need that. Little multiplication dot in there. X to the nth times x over n factorial times x to the nth. Okay. Here's where stuff just starts canceling out. So your n factorial cancels out. Your x to the nth cancels out. So just bringing that right on down here. It's equal to the limit as n approaches infinity of the absolute value of n plus 1 times x. Actually, we can get our absolute value of x and just bring that right out to the front. Because really, we're only going to increase the n. So that's going to equal the limit as n of, oh, forgot to write it down there. Of the absolute value of x times the limit. And I guess you don't need that because it's going to be positive, but I'll use the n plus 1. Anyway, as n approaches infinity. Now we know as n gets bigger and bigger and bigger, absolute value of n plus 1 just gets bigger and bigger and bigger. So that's just going to equal the absolute value of x times some really big infinite number. Okay. So this will only be less than 1 if x is 0. That's the only value that will make that less than 1. Anything else, it's just still going to be infinity. So it's only going to be convergent at 0. Okay, so by the ratio test, the series only converges remember, by converges, that just means that our limit is less than 1 when x is equal to 0, and diverges for every other value of x. For x not equal 0. So if you drew this on the number line, and that's your 0, it's only converging at one spot. So your radius at this point would equal 0 because it's not converging from 0 to 1 and -1. It's just at 0. So your radius of convergence is actually equal to 0 because it's only one spot. Okay. And even though they didn't ask for it, your interval of convergence is also just 0. It's no interval, it's just one spot. So also, your interval of convergence is just equal to, I guess you can put a bracket there, 0. So any questions on that so far? Takes a little bit of the glare off. All right. I'm still writing. Okay, so for our next example, let's say we want to find the interval of convert. Oh, I might as well go ahead and restart this since it's getting ready to shut off anyway.